5. So, Brandon, what's EMF?
The voltage use.
Yeah, go for it. I'm going to try and give me a sentence.
EMF is the voltage consumed.
Well, first let's say what it is. EMF is electromotive force. And an EMF of 1 volt in a circuit means 1 coulomb will convert into 1 joule of work. Okay. You got that? Okay, the next one. A battery can supply a current of 0.8 amps through resistor R1 when the voltage is 1.4, and then when R1 is replaced by a second resistor, the current goes to 1.2 and the voltage goes to 0.9. How'd it go? Did you fail it?
You didn't have the question. She didn't ask for it. She didn't ask for it. No.
What do you think you got? Where's your bag? Where's your bag? Dude, give me an answer. You're just mumbling. Where's your bag? How are you going to make notes?
I came in the morning with my bag.
Yeah.
So I went back home to get something. I thought it's because of the exam 1 physics class. I didn't come with the bag. But I didn't see it from Brandon.
Who's that?
I didn't. Let's look at you.
Somebody give that man a piece of paper and a pen.
Oh, thanks. I have a pen.
Your pen.
Dude, you're holding up the class. In number part B, what happens here is you have a battery, and then Ed, come on, how'd your speaking exam go?
Good.
Aced it?
Yeah.
Yeah? Who's your partner? Huh?
Chinese dude.
Chinese dude?
Yeah.
There's more than one Chinese dude at this school.
I can't remember his name.
What's he look like?
Tall, lanky, pretty tall.
Business student?
Yeah. Dark hair. All Chinese.
Dark hair, brown eyes?
I don't know.
Okay.
I didn't look.
Where's your pen and paper? You're holding up the good students who came with pen and paper.
You're welcome.
Now, whoa. Now, what's happening in this one? You have a battery, and then you connect it to a resistor, or 1, and you measure the voltage. And then you do it again with the same battery, just a different resistor, and you measure the voltage. And he wants you to get the voltage inside the battery, the internal voltage. Now if you open up your formula book, there's a formula and it goes, see, V equals EMF minus current times resistance. This is in the formula book and it's called like, it's given a name like voltage between two terminals. Anyways, just to explain, this is the voltage, this is the current, this is the resistance, and then what's this E here? EMF, the voltage of the battery really. And that's what you want. Now, the trick here is to recognize this. If I draw it as a graph, where in this experiment, what am I changing? I'm changing the resistor, yeah? And then I see a difference in the I, yeah? And then I see a difference in the, no, this doesn't change. I see a difference in the V. Okay, so anyways, imagine this. It's going down because of the negative here. But what do you think this point on the graph is? When this is 0, what's this going to be?
E.
E. Okay, so in fact, if you draw the graph, you're just trying to find this point here. Oh, sorry. This is not a big or. This is a small or. Oh. And this here is the resistance in the battery. Small r, okay? Now, if I look at this graph, and if I put V on the y-axis and I on the x-axis, does that make sense? Well, it does, because the or here doesn't change. That's the resistor inside the battery. So what is this or like for this graph? What do you think the or is like? It's like the slope, because the I is like the x, and this here is like the C. Very good. So he gives me 2 points. The first point he says, can you see it there? It's 0.8 and then 1.4, so that's there. And then the second point is 1.2 and 0.9. So the slope here should equal minus or. So the difference in the y's is 1.4 minus 0.9 over 1.2 minus 0.8. Can you tell me what that is? That would be, what's it going to be? 0.5 over... Oh, by the way, this is backwards here. If you do this one first, it's 0.8 minus 1.2. So that's minus 0.4. So you get or equals 1.25 ohms. Minus. No, we cancel the minuses on both sides. Now we want to find this one here. So we need to find the C. So we have y equals mx plus c. And how do I find the C? Use a point. Yeah, so I'll use this point here since I have it circled. 1.4 equals 1.25 times 0.8 plus c. So what's the C here, please?
0.4.
What is it?
0.4.
Okay, so in fact what I've just done there, that is part 4 of the question, and this one here was part 3. Okay? I skipped part 1 and 2, I'll actually do that now, sorry. Part 1, well actually maybe I'll draw it up here. Part 1 is he wants the value of R1 here. So what could I use to find it? What rule could I use? Yeah, I could just say V equals I or. So R1 equals V. What was the first voltage? we said it was 1.4 over I, which is 0.8. Okay, what's that, please?
1.75.
What is it?
1.75.
Okay, that is the answer for part 1. And then do the same here. Or 2 will equal 0.9 over 1.2.
0.75.
Oops. Okay, that's part 2 done. So part 1 and 2 was to use Ohm's law, and part 3 and 4 was to use the other formula we have. This is the voltage across the terminal formula. This question came up again in 2010. So I think they like this type of one. Anyways, are you okay with that? Yeah? Okay, so that's A and B. Now C. With C here, there's a 10 here and a 40 here. The first thing I'm going to do to make my life easier is to combine these into 1. So what formula do I use? 1 over R equals 1 over 10 plus 1 over 40. So help, you have calculators, go ahead.
0.125.
What is it?
E.
What's, yeah,
R is E.
thank you. Okay? So that means I can redraw this as follows. There's an 8 here, and there's a 60 here, and there's a 10 volt here, and he wants the voltage here. Okay? So firstly, we just really need Ohm's law here for this one. So if we look at this 10 volt here, 10, or what? Well, firstly, let's write down. What's Ohm's law? V equals IR. So this 10 here equals I. Now he doesn't give us I, does he? No, that's okay. Wait, hang on. V equals... I got confused now. Actually, you know what? Do you have the formula book there? I can show you there might be a formula for this one here. If not, I'll just do it. No, it's okay. It's okay. Forget it. No, it doesn't matter. I'll do it. Forget it. It's okay. It's okay. Okay, so V equals IR. So here 10 equals IR. And what's the OR here? 68. Because they just add now because they're in series, yeah? Is that okay for you? Alright. Now, I can get the I here. So can you just divide and tell me please what the I is?
0.147.
0.147 amps. Is that okay? Now, if I look here at this piece, oops. If I use Ohm's law here, what's the resistance? It's 60, isn't it? What's the I? 0.147, and this is the V he's looking for. So I have V equals IR. 60. Okay, what's that?
8.82.
What is it?
8.82.
Volts. That's it. It should be short because it's 3 marks only. Okay. This is actually a very special type of circuit, and the name of the circuit, it's a special type, it's called potential divider. Can I have that 6? Just want to check something here. Cool. Now, I don't know if it's in the formula book, but for this special circuit, there's a formula you can use to calculate the answer if you didn't want to use Ohm's law. I'll say that again. Look here. If you didn't want to use Ohm's law, there's a special formula for potential divider. And the formula is the voltage here equals, I'll call this the voltage 0, the input voltage. It will be, and if I call this R1 and R2, the formula is R2 over R1 plus R2 V0. And if you were to calculate it for this experiment, it'd be 60 over 68 times 10, which would actually be exactly the same as 8.82. Now, but I don't know if this is in your formula book. Does anybody have the formula book? Could they see if it's in it? Whoa. Dude. It's not in it, or it is in it? No, okay. You can remember it, or you can do it the way I showed you. Alright. D now. Ten. 5, 2, 3, 4, and that's it. Oh, I'm sorry, there's batteries here. And then there's a battery. I'll just retry this. There's a battery here, and there's a battery here. And then we have this one here. Okay, 50 volts and 4 volts. And he asks us to basically solve all those currents there. So he gives us the diagrams. The current goes up here and along here through this one. And then the same thing happens here. It goes up, up, and then what happens here? They meet. They meet and they go down. Okay? Now, he calls this one here I1. This one here I2. And this one here I3. And he asks us to use, do you remember this dude? Where have you been? Yeah, I know. They told me you were at home asleep.
Yeah.
Why is that now? Sit down. Okay. But I thought the whole point of fasting is so you go to school and you work hard and it's difficult and how long to go?
6 hours.
6 hours?
No, 7.
7 hours, yeah, 10 o'clock, yeah. Tough, huh?
You will survive.
Huh?
I will survive.
Will he though?
I hope so.
Look how skinny he is now. Okay, so here, calculate the current. So remember, Kirchhoff's has two laws. The first one is basically if you have two currents and they add together when they combine, you know, this one here. And then the second law is the voltage in a circuit has to be balanced. You know, so that makes sense. Of course, the voltage, the battery has to equal the voltage used up by all the other pieces. So let's look at the current first. The current first. So I3, what can we say about I3? What do you think? What can we say about I3? I3 equals, what do you think? I1 plus I2. Yeah? Are we happy with that? Now, let's look at, I'll do it in blue. Let's look at this battery and let's follow it this way, this loop. One of his laws also says that, wake up man, wake up, don't fall asleep on me, alright? One of his laws says the voltage in a loop must total to 0. Or another way of saying it, the battery must total everything else. That's his second law. So what's the voltage of the battery? 50. Now you might say, I don't know the voltage in the resistor, so we have to use which law now? Ohm's law. What's Ohm's law? V equals IR. So what's the voltage here? It will be 10I1. I mean, this is called his law, but I think of this more as Ohm's law, that the voltage has to total up to the battery, you know. 5I1 plus, what's the last one? 4 what? Not I1, 4 I3. Okay, and then finally let's look at, let's do this one. Okay, so you have 4 equals 3I2 plus 2I2 plus 4I3. Now I would be so lazy, I would just open up Derive and solve these 3 equations. How many unknowns? 3. How many equations? 3 equations. Come on, guys. You're not all fasting. 1, 2, and 3. Okay. If you were to do this the long way in the exam, what I think you should do is, you see you get I3 here? Hang on. You see you have I3 equals I1 plus I2? What I would do is, I'd take this I3 and put it here and here. And then what would happen? You would have 2 equations with just 2 unknowns. So you would substitute that into these 2. Do you understand? Okay. Now let me open up Derive here. Okay, so come on. Right, can someone write this down because Derive doesn't want to move. Dude, what's wrong with you? Come on. No, okay. I3 equals well, you all should be writing this down. Did you write this down?
Yeah.
Okay. Yes, you all have it? Alright. Brandon, give me the first equation.
50 equals 19I1.
50?
Equals.
That's not the first one. That's the first one.
Oh.
Did you write that down? Okay, let's try this again. Give me the first one, please.
I3
I3,
equals I1.
I1,
Plus
I2. Cool. What's the next one?
50
50, yeah.
equal 10I1.
Yep,
plus 5 I1
yep.
plus 4 I3.
Okay. And last one,
I1 plus I2.
what is it? 4 equals
3I2
3I2.
Plus 2I2
Yep,
plus 4I3.
right. Solve system 3 equations. 1, 2, 3. Uh-oh. One of our answers is negative.
Yeah.
That's bad. Did I write any of these equations down wrong? Ten, 5, 4, and then 4 equals 3,
I got
2.
I1 is 2.8
Yes.
and
I2 is a problem, it's negative. I can see it here.
Back negative.
And this is 2.
Maybe.
it's not.
Minus 0.
I did something wrong. Google is our friend. Come on. I wonder if it would have been different if I used the total outside loop. Let's see. Let me delete this for a second and let me try doing the whole outside. Okay, so what do I get? Okay. 50 equals 10 I1 plus 5 I1, is it? Now, look carefully please. Notice how I'm doing minus 2y. Why am I doing minus 2y? because the current is going the opposite direction, yeah. What's next now? Minus 3y, and then minus 4, because that battery is going the other way too. The y is negative still. Although, maybe it should be negative because it's going backwards. See here? It's going opposite to this. So it should be negative. So let me go back to what I had. Can you call out the third equation? 4 equals 3. Yep.
Plus 2i2.
Yep.
Plus 4i3.
Did you get this too? Oops. So we have 14 over 5. Yeah, okay. Let's write it down. So what's I1? What is it? 2.8 amps. I2?
Minus 0.8.
What is it?
Minus 0.8.
But because it's minus, this is going the opposite direction. So, what'll I say? Counterclockwise? And then I3?
2.
So this was part 1, part 2, part 3. Okay, now part 4. Which direction will the electrons be flowing through the 4-volt power source? Which way do the electrons flow?
Positive to negative.
Let's draw it here. So here's your battery. Here it is here. So which way does the current is going this way? So which way do the electrons go? Do they go this way also? Or do they go this way? Well, think about it like this. This is positive, isn't it? And what would attract positive? What would move towards positive? Negative. So the electron would want to go this way, wouldn't it? So that means it's going this way around. So I would say it's going down the page. It's going like, or if you want, clockwise. Because think about it like this. If you drop an electron in here, the electron will want to move where? To the positive or to the negative? It'll want to move to the positive, so it must be going this way around. Okay. Let's try this again.